Hi, my name is Fox. Welcome to Automation Workshop at Resolution Circle. Today we're going to be doing tutorials for Siemens logo, the software for the PLC we're going to be programming as we are doing our basic PLC programming in the workshop. The PLC at Siemens logo, it has 8 digital inputs. It has 4 digital outputs, and all of those 4 digital outputs are relay based outputs. So let's go straight to the software. This is the software that we're going to be using to program the PLC. When we start building our project, we go to File, we create a new project, then we can then select the language you're going to be using to program your PLC. Today in this tutorial we will be using ladder logic. You then select the language. After selecting the language, this is the page you're going to get. Let's say or when you are still programming, you see that you don't have enough space to program your PLC. You can then come here on page layout, you click and you can increase your layout, your vertical layouts. Let's make 2. As you can see now, I have enough space to build my ladder logic. If it's not enough, I go back, I increase my vertical pages. Okay, on our left hand side, it's where we'll find our instructions, our contacts, our time delays, our counters, everything we're gonna need in programming or building our ladder. On top here we have edit, we have format, we have view, we have tools. Tools is what you're gonna use most. When we select on tools, we have transfer. Transfer, it's where when you are done with your program, you now wanna download that ladder into a PLC. You then select the first option, of which is PC to logo. The second option is logo to PC. You then, if you select the second option, if you are connected to a PLC, it will then take the project or the program that is stored on a PLC to a computer so that you can see and you can simulate, you can manipulate and do everything that you want. You can then start your PLC or stop your PLC. But in this tutorial, our main focus will be on simulation. On this part of the page, we can do simulations here. This is where you will select. If I press here, then it will go to simulation mode. As you can see, my power line is now blue. Okay, so let us create a simple program so that you will see how to do labeling, how to do addressing, and all those things. What's nice with Siemens logo is that your inputs and your output are already addressed. They use a simple address I1, I2, I3, I4, I5, I6 for input that are linked to your input module. For output, it's Q1, Q2, Q3, Q4, so on, so on. So let us make a simple program of when you press the start button, your green light comes on. When you press stop, it then becomes off. All right, so you to build or to select contact or anything on your left hand or on your instruction list, you press and grab to this side of the page. Okay, now we have inputs. We have about 24 inputs, but we know that in a PLC that we are currently programming, it only has 8 inputs. So we're going to be programming from input 1 to input 8 if need be that we have 8 input. Then the second part, it will be where you'll now add description into your contact or add labels to your contact. For instance, on my start button, I want to indicate that it is a start. Okay. Then on simulation, here you'll then select if that particular contact is a switch or it's a monetary push button. So I want my start to be a push button. I select it and I press OK. I can then press and grab, put it on my page where I will be able to use it. Let me add stop. I want to use input number 2 on the input module or input card. I'll then select input 2. I want to know when I'm building, so that I want to know what is on input 2. So I'm going to add a comment also so that I won't forget. On input 2, I have a stop. I also want my stop to be a button. In this case, I want my stop, since I'm simulating, to be a normally closed. But I always prefer a normally open if I'm working with a physical push button that will be a normally closed. So on my program, I'll then make my stop button to be a normally open, because physically the push button will be a normally closed. But in this part of the tutorial, we are only focusing on simulation, so I'm going to leave it as a normally closed. I'll then select my output. My green light will be on Q1. I'll also add some comment so that I won't forget what is Q1. I'll say it's a green LED or green light. Okay, now I have my input and my output. In this small project, I'm demonstrating how to make a simply latch. I'll then add a line here. On my block name, I can then change this input to be what I want. I don't want it to be an input. I want it to be my Q1, because I'm latching Q1. So whenever Q1 is energized, it will change the state of this contact, and power will then flow through Q1 to continue to power my output. Okay, I'm done with my first program. I can then simulate to see if my program is working the way I wanted it to be. I'll then select simulation. When I press simulation, then everything is now online. Here I have my input 1, I have my input 2. I know my input 1 down there, you can see where my pointer is. I have a monetary push button make. I have monetary push button make. here I have my Q1, my green light. So when I press here, oh, my Q1 is now on. I can either press on exactly the push button, or I can press here when I'm doing my simulation. Then I wanna stop it, and I press my stop, and I just delatched my green light. That's how simple the software is. Let's try other things. Let's try things like time on delay. Let us make our project to look more interesting. Let's say you want your light to be on, let's say 3 seconds after your push button was pressed, and when you press stop, it must be off immediately. Okay, so in that we will need a memory flag, an internal flag. On our previous video we mentioned, or we spoke about internal flags. They are not linked to your IO module, they are just within your program, but they are not in your input output card. So on my block name, that's where I can declare that I want this coil to be a memory flag 1. Then I select and I press. I can then name my memory flag so that I won't forget what is it. Let's say I'll call it my flag 1. Okay, so anything that is linked to it, you see it has that command. You can change, you can move this command of yours to anywhere you want, on your left or on your right, depending on how you want your program or your ladder to look like. Okay, I'll then need another contact that will be the one that will actually I'll need my time on delay so that when 2 or 3 seconds has elapsed, my LED should be on. So with this this retailer, I'm trying to make a latch. When I press start, remember a push button you press, the moment you release, there is no longer current flowing. So I want this to be a self-powering while I'm no longer pressing the start button. When my flag is energized, I also want my timer to be powered. I'm using a time on delay. From our previous video or from our note, we know that time delay, we have two types. We have time on delay and we have time off delay. With a time on delay, your output will be on after a delay time when your trigger or your input was a high, of which is different with your time off delay. Time off delay, for it to start counting or to start delaying, your input or your trigger must move from a high to a low. Then it will then start counting. And whenever your input is a high, your output will be a high immediately. But we're gonna, when we're done with this simulation, we're gonna do of the one for time of delay so that you will see how time of delay works. So I will call this my T1 or delay 1. And I want it to count 3 seconds. Okay, I can then make a contact that is linked to my time delay. On my block name, that way I'll search time. Like I just type T and it just took me straight to the time delays. And then I click. I can then move it to the second rung, select an output of which is my green light, because I said I want my green light to be on after 3 seconds the push button was the start button was pressed. I don't know what happened to my comment. Let me add my comment again. It's a green. Okay, now I have my green. Okay, so let us simulate to see if it works. As you can see, this is just a memory flag and Q is my output. I1 on the bottom, check my cursor, it's your start. I2 is your stop push button. When I press, as you can see, it was off for 2 seconds, then now it is on. When I press stop, everything goes off. So let us add a time of delay so that you guys can see how it works. Let's say we want to have a second light that will be off. Or we can have a light that is initially on and it's gonna be off when your stop button, or it will be on. It will be off when your start button is pressed. But when nothing is pressed, it should be off. Let's say we have red, that will indicate that our system is off. Let us just add red. If I want to select this rung and push it down, I have to come here and make this selection, because with this connector, I can move my contact to anywhere I want, but I can't select this contact and this contact down. But with a selector, I can then highlight everything I want to highlight. When everything is highlighted, I can then press and hold and grab down. I want to put it down there. On the same line, I want to put a time of delay so that when a stop button is pressed, it will then start counting. Okay. Let me connect it together with this. I want my time of delay to switch on red light that was initially on before I press start. But when I press start, it became off. And when I press stop, I want it to be on 3 seconds after a stop button was pressed. Let's also give it 3 seconds. Let us say call it delay red. Okay, so I will have to select this one, link it to my time delay, so I will have to press T. So I have my on delay and my off delay. So I want to use my off delay for this function. Then I place it. So I want my output to be inverted. When my output is powered, it will be off. But when it's not powered, it will be on. So when I come to my constant, instead of using a relay call, I'll use an inverted output. Okay, when I select, my Q2 will be inverted. As you can see, there is a line inside it. Then I will call it my red. Okay, when I press simulation now, you see my red is on initially, even though there is no power going to it. My time delays are off, everything is off. When I press start, now you see it's powered because my time of delay was powered. Let me increase time delays so that you will see exactly what is happening in this system. Let me say 5 or 10 seconds also. Okay, and I press stop. It's counting. 10 seconds. Good, everything is off now. Let me reduce time for my time of delay because it takes long. Okay, so now my red is inverted. So when my rag is not powered, my output will be on. As you can see down there, my Q2 is on. I'm not sure if it is that point clear. Let me include another output, a normal output that is not inverted on the same line, so that you'll see the difference between the two. And I'll call it, let's make it to be, let's say, orange or yellow. Orange, yeah, orange is good. Okay, so that you'll see the difference between the inverted output and uninverted output, or a normal output. Okay, you see my Q2 is on, but Q2 and Q3 are on the same rung, but my Q2 is on because I used an inverted output. Alright, the purpose of this is to show you how time off and a time on delay works, and how an inverted output works. So when I press my input, you see my Q3 is on because my time off delay is powered, even though my time on delay was still counting, but my time off delay was already powered. So with a time off delay, the moment your input is powered or your trigger is powered, the state of your output will change. If it was a normally open, it will be a normally closed. If it was a normally closed, it will be a normally open. As you can see now, my green is now on. Remember, green is linked to my time on delay. Let's see what happens when we stop powering our time delays, both time on and time off. Let's press stop. You see both of them are not powered, but look at my Q3. My Q3 is still on for 5 seconds because it's a time of delay. It delayed to switch off the output. The moment we reached 5 seconds, it was then off, and my red came back again because my red is initially on because I'm using an inverted output. Alright, that's how our time delays work. Right, let's say now we want to add a counter. Let's say for our For our green light to be on, you have to press your start button, let's say 3 times. Then your green light will then be on. So for that, let me not disturb what I'm doing here. Let me just create a new project so that I won't make something that will look untidy. Then I select my make contact. I select my normally open. I still want it to be my starter. I want it to be a push button. Okay. And I want an up-down counter. So let me explain a counter. A counter has up-down counter. It has 3 ports, as you can see. The first one is for reset. The second one is for counting, and the third one is for direction. So for now, let us focus on the counter, the second port. I connect it, and I bring a contact. I said I want my green light to be on when I've pressed the button 3 times. Okay. So I'll then select here on my block name, I want C for counters. Okay. And here is my up-down counter. You see the C1, the C2, the C3, the C4. These are the buttons, the physical buttons on the PLC. Let's say you want to use those buttons for incrementing or decrementing. That's where you can address them or add them to your program. If I double click on my counter, I'll say I want my output to be on when I've reached 5. When I go below 5, I want it to be off. But in this part of simulation, like right now, it won't be off because we are just demonstrating when we click the counter 5 times what will happen. I said this one will be our green light. Okay. Let me make my connections. Right. Then I simulate. So I come, I press 1, 2. You see the counter is counting up. 3, 4, 5. The moment I reach 5, my Q1 is now a high. As you can see, my Q1 is on. But there is nothing that will make my system or my Q1 to be off in this case. So let's say we want my Q1 to be off. I'll then reset my counter. For me to achieve that, I'll need a push button. That will be my reset. I'll use input 2 for that button. I need it to be a push button, and I'll call it my reset. Or you can call it your stop or your emergency, or yeah. Okay, then I connect. I push this so that it will look nice. Okay. Let's simulate again and see. When I press 1, 2, 3, 4, 5, my Q is on. When I press reset, it reset back to 0. Okay. Now I can reset my green light. But let's say now I want to count the number of people um, going inside a restaurant. I want to count uh, the number of people in the restaurant. Like for instance, if the lockdown or the regulations of the country says in the restaurant you can only have this number of people. Just like when you go to big supermarkets like Pick and Pay, like they give you things like packs so that they will uh, be able to trace the number of people going inside the shop. When you go inside, you take a pack. When you go out, you then bring it back. Then that how they can calculate that, okay, we are still within the boundaries. So let's say we want to automate that system instead of having that particular person standing at the door giving you packs. That might be also a way of transmitting the virus. We can automate that system. Like we can have a sensor that will detect when someone is coming in, and we can have a sensor that can detect when someone is going out. So for us to achieve that, we will need an up-down counter. Let's say when we reach 10 people, let's say now the shop has 10 people and the regulation says the shop can only have 10 people, then a red indicator should come on to say we've reached the limit. We will use green as our indication to say people can still come in, and we'll use red to say the shop is now full, no one must come in. All right, so for that we will need to be able to count up and to count down. Remember, on the previous video or on our note, we discussed that the up-down counter for this PLC, when the direction is powered in this port, it will count down. When the direction is not powered, just like now, it will count up. Just like now, it acts as an up counter. But if your direction is powered, it will act as a down counter. If you are able to power and cut the power going to your direction, then you can achieve making it an up-down counter. So how are we going to help Pick and Pay to solve the issue of pegs? We still need our green, so we're going to push it down. The thing that now we need is it's our sensor. Okay, so we're gonna need a sensor at the door from inside. The sensor that will before the door inside the shop. When someone is about to leave the shop, the sensor will be there inside to say, okay, this person is now coming out, like a motion sensor. All right, so I'm going to use input 2 to connect that sensor. In my simulation, I'm going to make a sensor to be sorry guys, 2 is already used. You see input 2, it's already used as our reset. So let us give it input 3, and we're going to call it exit sensor. I want it to be we'll have to make our sensor to be a switch, not a push button, because for simulation we can still make it a push button, but we'll have to latch it. It's gonna be a process. So for now, let us make it a switch. It also will help you to see how a switch works. Okay, we then connect it to direction. Let me push this to be here so that it will look nice. All right, so now we have exit sensor, and so here I can't have green. When I've reached 10 people in a shop, I don't want anyone to come in, so I need Q2 here. I need Q2 which will be red. Right, now we have a red light. We still need our green to say people can still come in. So we can take a normally closed, we link it to our counter. Okay, then we can have an output going to a green light to say people are still welcome. And my start will then be the sensor at the door. So the sensor at the door, it's either it's the sensor that detects if someone is passing the door, whether coming in or going out. So this is the I input one. It's a sensor. It will be a door sensor. A door sensor. It's gonna be a push button. Then I3 will be exit sensor, the sensor before the door. When someone is approaching the door, then it will then detect that there is someone from the shop going out. Okay, let's simulate and see if our system works. Okay, as you can see, my green is on. Q1 is on. People are still welcomed in the shop. So a first person goes in, the second person, the third person, fourth person goes in. People keep on going. Let's say when the seventh person is inside, the first person is done buying what they are buying. They are now leaving. The sensor detects a person, my I3. Then when the door sensor, the person passes the door, it will then start counting down. Okay, the person has passed the door. I operate a switch, say there is no one. Then another person comes in, another person comes in, another person comes in. Now people are 10 in a shop. Then my red is on, my green is off. So people are no longer allowed to come in. So for another person to come in, the second person or the third person must leave. Then the sensor will detect if the person is leaving the shop, then it will then start counting down. Another person wants to leave, detects. You see, as much as my direction is powered, my counter is counting down, down. People are leaving, people are leaving. Let's say now there is some emergency, or there is emergency and people must use the emergency exit or somewhere, and the shop is now empty. We must be able to reset our system to say, hey, there is no one in the shop. When we press reset, our system starts afresh. Well, the system doesn't look nice because I'm using a push button. I'm using a sensor. I have to operate it now and then. Let's make this sensor, the exit sensor, to be able to be to switch itself off when someone has left, instead of me clicking and clicking and clicking and clicking. Okay, for that, let's move this down, these two, because we are done with them. We're still using them. We can say our i3, I no longer want it to be a switch. I want it to be a push button. Okay, now my i3 is a push button. I want my push button to, whenever it detects someone approaching the door to leave the shop, to latch. For me to be able to make that, I'll need an internal flag. Internal flag, I'll call it way out. Someone is on their way out of the shop. Way out. Okay. Yeah. So I want this to delatch when someone has passed the door. I can make my door sensor to be the one that will delatch, to say that person who was on their way out have now passed the door. That person is now out. Okay, I select my M1. Okay, so now this, instead of me clicking when there's someone, I want it to do itself, to trigger itself or to delatch itself automatically when someone leaves the shop. Let's simulate now to see the improvements in our system. Someone goes in, someone goes in, then someone is on their way out. The sensor detects them. My way out, you see, is now powered, or it has latched. Then when the person passes the door, it then counts down. When another person approach on their way out, the exit sensor detects a person is coming. Then it make our counter to count down. Then it decrement. Let's say in the meantime someone is coming in. When I press without the sensor detecting anyone, which means it's someone coming in, not someone exiting. When I press the door, when that person passes the door, the counter goes up. When that person passes the door, the counter keeps on going up. The counter goes up, goes up. Let's say another person is leaving the shop. The sensor detects. When the person passes the door, they say, oh, someone is out. So that's how this works. Right. Okay, guys, this is a demonstration of a counter. So surely you have seen how simple and how Siemens logo is. So below I'm gonna drop a link where you can get a demo version of Siemens logo, so that you can start simulating or practicing your simulation codes. You can simulate other languages so that you will be good. Things like function blocks. This is where you can do your function blocks. You can have your inputs. You can have your logic functions. You can have this is another language. You're gonna do this when you are exploring. say I want my output to be on when both switches or push buttons are pressed. Let's say switches are pressed. Okay. Remember how the AND gate works. For you to have a high, all your input must be a high. Okay. So when this is high and this is high, then my output will be a high. So this is another language. It is a great language to master. We're gonna be posting a video for it soon. Now, can you please like the video so that in future you'll be able to find more tutorial easily, and you can subscribe to the channel. Stay safe. See you in the workshop. Thank you.